Okay, this video is going to be about divisibility rules and little chants that will help us remember our divisibility rules, geared towards anywhere from third to, third grade and up pretty much needs to know these divisibility rules. It makes it easier to find common factors for things, to reduce fractions / simplify fractions, and other things. So I have divisibility rules for 2, 3, 4, 5, 6, 9, and 10 listed here. And we're going to pick different numbers and test the divisibility rules. So our first number is 321, and we're going to check if it's divisible by these numbers on the left-hand side. The divisibility rule for 2 is 0, 2, 4, 6, 8. Who do we appreciate? Even numbers. If there is a 0, 2, 4, 6, 8 even number in the ones place, it could be divided by 2 evenly. So let's check out the ones place. Right here. And that is not an even number, so that means that this is not divisible by 2. So we're going to check for 3, 4, 5, 6, 9, and 10. Those are the ones that we're going to check for. Divisible by 3, add them up and see. So the rule for 3 is if you add up the digits and that is divisible by 3, then the entire number is divisible by 3. So divisible by 3, add them up and see. So we're going to add these digits. This is the rule for 3. 3, 4, 5, 6. 6 can be divided by 3 evenly. 6 is divisible by 3, so that means this entire number is divisible by 3. And there's systematic reasons for that because, when we get to 99, we know that's divisible by 3, and so adding up the digits is a good way to figure that out, and that works for 3 and 9. Now we'll use the rule for 4. Tens place or more, divide by 4, and when I say tens place or more, I mean the last 2 digits. So it's not really like more than the tens place. It's tens place and more, divide by 4. So these last 2 digits, I'm going to divide by 4. The caveat to that, or is it double 0? So if it is double 0, then it also is divisible by 4 because 4 can go into 100. So anything that has a double 0 on the end is divisible by 100. So we check for double 0 and we check if the last 2 as a whole, not adding them, but just as a whole, if they can be divided by 4. That means the entire number can be divided by 4 because we know 4 goes evenly into 100. So I have 21 as my last 2 digits. 21 cannot be divided by 4 evenly, so this number is not divisible by 4. 5 rule. If there's a 0 or a 5 in the ones place, the number is divisible by 5. So we check out our ones place again, and it is 1. It is not 0 or 5, so this number is not divisible by 5. 6. Since 2 times 3 equals 6, oops, mistake. My dog is literally following me around and just making noise, so that's super. Sorry about that. So since 2 times 3 equals 6, if a number is divisible by both 2 and 3, it will be divisible by 6. So this number is not divisible by 2. So nope, it's not going to be divisible by 6 because it needs to be divisible by both numbers. The rule for 9, if 9 is what you see, steal the rule from 3. So we're going to add up all the digits and see if this new number can divide by 9. So it's the same as 3, except for now we see if the number could be divided by 9 evenly. So 3 plus 2 plus 1 is 6. That cannot be divided by 9 evenly. So this is not divisible by 9. And then the rule for 10 is divisible by 10 if there's a 0 at the end. So if there is a 0 at the end in the ones place, it could be divided by 10 evenly. And that is not the case here. Let's try another number and hope that my dog does not make noise. It's a little sad when you're out of breath from just walking around the house, but you know, whatever. We all have our issues. Okay, so let's try a larger number here. Let's try 1024, and we're going to use our same divisibility rules. So the rule for 2 is 0, 2, 4, 6, 8. Who do we appreciate? Even numbers. So if we look at our ones place, if that is an even number, the entire number is even. Here we go. It is an even number, so this is divisible by 2. Okay, 3. Divisible by 3, add them up and see. So let's add up all the digits. And if this new number can be divided by 3 evenly, then the whole number is divisible by 3. So 4, 5, 6, 7. 7 cannot be divided by 3 evenly, so this is not divisible by 3. Tens place or more divide by 4. What I mean by tens place or more is the last 2 digits making that one number, not adding them, but just looking at it as one number. So the number 24, can that be divided by 4 evenly? Yes, it can, 6 times. So 4, either if it's double 0, or if the last 2 digits can be divided by 4, then the whole number is divisible by 4. So that one works. 5, if there's a 0 or a 5 in the ones place, the number is divisible by 5. No 0 or 5 in the ones place. 6, it has to work for both 2 and 3 to be divisible by 6. Since this number is only divisible by 2, that means that it is not divisible by 6 because it has to be divisible by both 3 and 2. 9. If 9 is what you see, steal the rule from 3, but divide by 9 instead. Okay, so we're going to add up all these digits again. 4, 5, 6, 7. 7 cannot be divided evenly by 9. So that means that this entire number is not divisible by 9. And finally, divisible by 10. If there's a 0 on the end, there is not a 0 in the ones place, so this is not divisible by 10. So we have the divisibility rules that this number is divisible by